Sir, am I audible? I cannot hear anyone.
Good evening to all.
Yeah, good evening, sir. Thank you. I can hear you now.
Okay. Beta, can you hear me?
Yes, sir.
Okay. Ajay, how are you?
Yes, sir. I can hear you.
Okay. So, what is the last class, beta? What I taught in last class?
One second, sir. Let me look at my notes.
Beta, what I taught in last class?
Sir, we learned about sets.
What's it, beta?
We left on finite set, I think.
Finite set or infinite set?
Oh, infinite set.
Or equal set?
I
This
have
topic.
my notes till infinite set. Maybe I missed.
Influence. Beta, what I taught in last class, beta? Please let me know, please. Firstly,
Types of sets, sir.
types of set. Which one?
Till infinite set.
Infinite is done now.
Yes, sir. That done infinite set.
Okay. So, beta, after beta set, we start the topic on MOD, method of differentiation. Okay. So, next topic is. So, next topic is beta. Your next topic will be equal set. Okay. Equal set. This is your next topic, equal set. Okay. So simply two sets A and B are called equal if every element of set A is an element of B and every element of set B is an element of set B. Okay. So if A and B are equal sets, then we write A is equal to B and if they are unequal, unequal, then we write A is not equals to B. A is not equals to B. Okay. So fundamental example, let us consider here, beta. So basically, beta, you can say simply now, guys, just consider here. You can say simply कि if all elements of A are present in B and all elements of B are present in A, then we can say that A and B are equals. Okay. So I think no any confusion about my statement. All elements of set A are present in B and all elements of set B are present in A, then we can say that the A and B are equal set. Then we can say that the A and B are equal set. This is clear or not? Okay, so basically, beta, I will also say if two sets A and B are called equal if every element of set A is an element of B and every element of set B is an element of set A. So if and B are equal set, then we write A is equal to B, and if they are unequal, then we write A is not equals to B. That is the basic statement about the equal set. So let us consider one example here. Simply with one example. Let's say A is equals to 1 to 4, 1 to 4, and B is equal to simply X such that X is equals to 2 to the power Y, and Y is equal to 0, 1, 2. Are beta clearly equal sets. Are clearly equal sets. Okay, beta. So I think this is clear to all. Next one is that equivalent set. Equivalent set. Okay. So simply two finite sets A and B are equivalent if they have same number of if they have same number of elements. If they have same number of elements, that is n of A is equal to n of B. Okay, that is n of A is equal to n of B. So, beta, one simple statement is that, guys, if cardinal number will be same, guys, if cardinal number is same, then we can say that this is equivalent set. Example, basic example. Let's say A is equals to 1, 2, 3. Okay, and B is equal to 4, 5, 6. So guys, just consider one thing here. What is n of A? Simply, beta, n of A is equal to what? 3. And what is n of B? N of B is equal to 3. So clearly, beta, clearly, n of A is equal to n of B. Okay, clearly, n of A is equal to n of B means what? Means beta ki A and B are equivalent set. So simple statement. I think no need to any explanation there. That's totally clear. Okay. This is clear, guys.
Yes, sir.
Okay. Next is so that is I will not discuss more than thing here because we start the calculus. So I think that we cover the thing in hard and fast. Okay. Next topic is subsets and superset. Okay. Subset and superset. Okay, beta. So basically, I think you're also familiar with this thing. Simply, beta, if if every element, if every element of set A is an element of set B. Okay, if every element of set A is an element of set B, then A is subset. A is subset of B. Okay, and one important statement is that B is superset of A. Okay, B is superset of A, and we write like as this. Okay, like as this. Okay, beta. So basically, if all elements of A are present in B, then we can say that the A is the subset of B and B is the superset of A. So that is the fundamental statement. So basically, just one fundamental example. Simply A is equal to what? 1, 2. B is equals to 1, 2, 3. C is equals to 1, 2, 3. Okay. First statement. First statement is that A and B are subsets of C. Okay, and you can say that the A is just wait 1 minute. Some mistake here. If you just take simple one example, let's say if A is equals to, let's say 5, 7. Okay, and B is equal to 1, 5, 7, 9. 1, 5, 7, 9. Then A is the subset of B. Okay, so simply with here A is subset of B, and B is superset of So A is subset of B and B is superset of A. So I think this is clear to all. Okay. Okay, beta. This is clear now.
Yes, sir.
So our next is that beta proper subset. If A is subset of set B. Okay, such that A is not equal to, guys, just consider A is subset of set B such that, okay, such that A is not equals to B, then A is called then A is called proper subset of A is called proper subset of B and we write A is the proper subset of B. So let us that's a simple thing, but that all the elements of A are present in B, and we should have at least one extra element. So beta, we can say that A is the subset of B. A is the proper subset of B. Means what key? All the elements of A are present in B, but we should have at least one extra element. But we have some more extra element in comparison of A. Okay. So one basic example. Simply A is equals to 1, 2. Okay. B is equals to 1, 2, 3. C is equals to let's say 1, 2, 3. Okay. So we can say that we have A, B are subsets of C. You can say that A is proper subset of C, but B is not proper subset of C, as B is equal to C. I think beta this is clear to all. Any doubt here, beta? Guys, have you any doubt? Please let me know. Beta, this is clear, na? Everything fine.
Yes, sir.
Yes, sir.
Okay. So beta, so this is only important thing which is also required for your class 12 starting area. So I think beta, this is clear to all, and this is your all basic. I will also cover for which is useful in class 12 thing. Okay, so no need to beta wastage of time. No need to beta waste some more time. So from right now, beta, we start the class 12 section. So basically, guys, I will start the chapter called class 12. Calculus. So, but in calculus, our first chapter is relation and function. This is your first chapter. So second chapter is beta limit. Third chapter is continuity and differentiability. Fourth chapter is method of differentiation. Fifth chapter is AOD. Sixth chapter is indefinite. Integration. Second chapter is definite integration. Eighth chapter is area under the curve. Ninth chapter is differential equation. And one important topic, number 10 is ITF. This is the section of calculus up to here, up to 9 number. This is the better section of calculus. So guys, here, this topic is very important because their position is 4, but this is very important. So I think beta, I will start from differentiation and then completion of differentiation beta, I will cover this topic, relation and function. Then beta we cover limit, then continuity differentiability, then AOD, then after integration. So guys, have any advice? Just tell me. Do you want to say something? Just tell me beta. Any doubt beta? Just tell me. Rituraj, Nina Garaj, Lockye, Manuri, DM Ajay. Beta, you people have any doubt?
No, sir.
Okay, so beta, any suggestion, any advice?
No, sir.
Okay. So I will start beta. Chapter called differentiation. So that is the very important and very most important, not important, very most important section of calculus, which is known as differentiation. Okay, guys, which is known as differentiation. So you can say that not beta, you can say method of differentiation. Method of differentiation. Or you can say that, okay, or you can say that differentiation. Method of differentiation or differentiation. Okay, beta. So this is the very important chapter, but I will start first, and after completion of differentiation, I will beta start chapter called function and something. Okay. So guys, do you know something about differentiation? Do you know anything about differentiation? What is differentiation? Please let me know. Any idea about differentiation? Any idea? Guys, any idea about differentiation? Just tell me. Please give me any reply.
No, sir.
Nothing. I will discuss everything. Don't worry about it. Don't worry, boss. 1 second. What? Same है ना? एक साथ कर लूं? ठीक है, दोनों का कर लूं। हाँ हाँ मैं देखता हूँ। हाँ ओके सो बेटा दिस इज वेरी इंपॉर्टेंट चैप्टर and this chapter is called method of differentiation. So it is starting from very basic beta introduction. Introduction. So beta the derivative of the derivative differentiation is also called derivative. So the derivative is the instantaneous 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 rate of change of a function with with respect to with respect to one of its variable one of its variable. So beta differentiation means what? If a differentiation is derivative, you are also familiar of this word in subject called physics. Guys, in physics, you have to differentiate anything many times. है ना? Every time beta differentiation word is in beta physics. Okay, guys, this is clear or not? Beta in physics, na, this term is also come in beta physics. Do you know? Guys, please give me reply, beta.
Yes, sir.
Okay, this is very basic terminology, beta. This is very a famous term. That is very famous chapter in the physics. Without differentiation, physics is beta meaningless. Okay, in every time you have to differentiate the thing. You have to differentiate the electrostatics. Every chapter, Newton's law of motion, friction, work, power, energy. Every chapter. So simply, beta, the sense is that differentiation is what? The derivative is the instantaneous rate of change of a function with respect to one of its variable. This is the basic introduction. Okay. So one important thing, if y is equal to fx, then then the then the symbol then the symbol is beta simply dy by dx, that is equal to capital D small y, that is equal to f dash x. Okay, that is equals to y1, or you can say that y dash have 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 the same meaning same meaning which is which is which is derivative of which is derivative of y with respect to x, which is derivative of y with respect to x. So differentiation is represented by dy by dx or capital Dy or f dash x or y1 or y dash. Okay. So that is the basic terminology about the differentiation. I think guys, you all are clear.
Yes, sir.
Okay. So but the differentiation is what? Dy by dx means what? But dy by dx means that the differentiation of y with respect to x. Okay. Dy by dx means what? Dy by dx means beta differentiation of y with respect to x. Yeah, instantaneous rate of change of y with respect to x. Okay, instantaneous rate of change of y with respect to x. I think beta this is clear to all. Okay, guys, this is clear now.
Yes, sir.
Okay, beta. So we move forward. Derivative of standard functions. Derivative of standard functions. Okay. Derivative of standard functions. Okay. So beta, first important result is differentiation of x to the power n with respect to x is equal to n into x into the power n minus 1, where n belongs to real number. Where n belongs to real number. Differentiation of x to the power n with respect to x is equal to nx to the power n minus 1, where n belongs to a real number. Okay, I think this is clear to all. Okay, beta. So differentiation of x to the power n is equal to n into x to the power n minus 1, where n belongs to integer and n belongs to a real number. This is the first question. First beta formula. Second formula is differentiation of a to the power x with respect to x. So beta differentiation of a to the power x with respect to x is equal to a to the power x. So beta that is very important formula which is useful for you. Third is beta differentiation of a to the power x with respect to x is equal to a to the power x ln a. ln a, okay. And beta condition is beta a should always be positive. Okay. So guys, you're also familiar with that beta. Just consider beta log n to the base a. What is the condition, guys? Just consider that. Just consider, guys, one important point. The log n to the base a. What is the fundamental condition? The condition that the n should be positive, a should be positive, and a is not equal to 1. This is the condition of log n to the base a. Okay, this is clear now, beta. And my dear friends, log a base e. This is, in short, you can say that ln a. And this is called beta. The log which base e is called natural log. Natural logarithm. Okay, natural logarithm. Okay, or log a to the base 10 is equal to, simply you can say that log a, and that is base is what, 10. So you can say that common logarithm. What? Common logarithm. Okay. Base e is called natural logarithm and base 10 is called common logarithm. Okay, log a base 10. Okay, log a base 10. Base is 10, then it is called common log. Base e is better simply said as natural log. Okay, and log a to the base e is simply said as log ln a. ln a. Okay, beta. This is the formula number 4. Formula number 3. 4 is beta differentiation of ln x with respect to x is equal to 1 by x. So differentiation of ln x with respect to x is equal to 1 by x. Okay. Fifth one is differentiation of sin x is equal to cos x. Differentiation of cos x is equal to minus sin x. Okay. Differentiation of tan x. Differentiation of tan x is equal to sec square x. Differentiation of cot x is equal to minus cosec square x. Differentiation of sec x is equal to sec x into tan x. Differentiation of cosec x is equal to minus cosec x into cot x. Differentiation of sin inverse x is equal to 1 upon under root of 1 minus x square. Differentiation of cos inverse x is equal to minus 1 upon 1 by under root of 1 minus x square. Okay, differentiation of sine cos inverse. Okay, differentiation of tan inverse of x is equal to 1 by 1 plus x square. Differentiation of cot inverse of x is equal to minus 1 by 1 plus x square. Differentiation of sec inverse x is equal to 1 upon mod x into x square minus 1, 16 number. Differentiation of cosec inverse x. Cosec inverse x is equal to minus 1 upon mod x into under root of x square minus. So that is your thing. So I think guys, this is a standard result. So first of all, beta, you have to remember this result. Okay, this is very important result, very basic result. So firstly, you have to remember this result. Okay, guys. Okay. So one is 60 result is you have to remember beta. One is 60 result. So this is clear, beta. Just note it. Note it on beta. Okay, done. Done, beta. Please tell me.
Yes, sir.
Okay. Next thing. The next thing is that we discussed here algebra of algebra of algebra of differentiation. Algebra of differentiation. This is very important point. Algebra of differentiation. Okay. So basically, let's say you have two functions, u plus v. I have to differentiate the function u plus v. So u plus v, differentiation of u plus v. So we can say that u plus v dash, u plus v dash. So what's the answer? U dash plus v dash. Okay, u dash plus v dash. Okay. Next one is that u minus v dash. The differentiation of u minus v. So u dash minus v dash. Okay. Third one is that differentiation of u into v. U into v dash. So first to differentiate the u and just multiplied with v plus just differentiate the v and multiplied with v. Okay, we can simply again just differentiate the u into just to differentiate the u. So answer will be u dash into v plus v dash into u. Okay, u dash into v plus v dash into u. Okay, beta. This is clear or not? Beta, this is clear.
Yes, sir.
That u by u upon v, differentiation of u upon v. So beta, this is called product rule. This is called product rule. So this is beta of u by obviously u by v, and you have to differentiate u upon v. Okay, so u upon v means what beta? U upon v means what? Simple thing beta, u upon v. Okay, so what you can observe here beta? Simply guys, sir, u dash v minus u v dash or divided by b square divided by b square. This is called percentage. This is called percentage. Okay, this is called percentage. So beta, algebra of definition is that, and the next one is that this is the rule number 1, this is the rule number 1, this is the rule number 2, this is the rule number 3, this is the rule number 4, and rule number 5 is beta, keep k into u dash. Okay, k into u dash. So k is the constant function, it is outside from the function, and simply beta u dash. Okay, so I think beta this is clear to all my dear students. Okay,
Yes,
Yes,
sir.
sir.
guys, this is clear or not?
Yes, sir.
Okay, I'm just better covering from basic. No need to better worry about it. So, better let's suppose in general, let's suppose in general, my dear student, in general, we have two functions, f1x, okay, plus f2x, and both are the function is operated by addition, and we have to differentiate. Okay, boss, we have to differentiate. We have to differentiate this function with respect to x. The differentiation of f1x plus f2x is what? So, sir, no problem, sir. We have to differentiate separately. So, differentiation of f1x, differentiation of f1x, okay, बच्चों, plus differentiation of f2x. बच्चों, this is clear ना? This is clear ना बेटा?
Yes, sir.
Differentiation of 1x plus differentiation of f2x. Next thing, same situation. One number. Number 2. f1x, beta, calculus is very important section, beta, very important section. But I'm very feel cool when I beta teach calculus. I just I'm heaven of world. Okay, because I'm also beta, my calculus section is very topmost important section across the India. Okay, I'm also beta, you just search on the Byju's, my calculus watching hour is beta 9 million. Okay, so I'm very proudly say that calculus is, this is my chapter. Okay, this is my section. So if you differentiate the first function minus if you differentiate the second function. Guys, this is clear now?
Yes, sir. Sir, isn't
Okay.
it the same as the algebra differentiation thing you gave before?
Yeah. That is the beta, that is the particular condition, that is the general condition in the algebra of definition. Okay, in algebra of definition, algebra of differentiation.
Yeah.
Algebra of because we have to consider u and v. So I think some students are not familiar about the u and v. So here, beta, I will discuss there simply function f1, f2, something. Okay. Third number. Differentiation of constant, differentiation of k into fx. Differentiation of k into fx is equal to k is outside from the differentiation, and to differentiate the function with respect to x. With respect to x. This is clear to all. बच्चों, this is clear, no? Okay.
Yes, sir.
So just come on the some standard example and some basic example. Okay. So let's discuss some examples. Okay. So let us first question. What is the differentiation of sin x So your simple answer will be, sir, cos x. Next one is that, sir, differentiate what? Sin x plus x. Okay, sin x plus x. No problem. First, you differentiate of sin x with respect to x. Then differentiate x cube with respect to x. Okay, so differentiation of sin x is cos x, and differentiation of x to the power 3. So beta x to the power 3 is like as the beta x to the power n. So n into x to the power n minus 1. So beta simply 3 into x to the power 3 minus 2 is simply 3x square. I think beta this is clear to all. Beta clear now?
Yes, sir.
Okay. So beta this is your answer. This is your beta answer. Okay, beta. This is clear to all.
Yes, sir.
Okay. Next one is you have to differentiate tan x plus sin x. No problem. First, you differentiate tan x with respect to x. Then you differentiate sin x. Okay. So differentiation of tan x is sec square x, and differentiation of sin x is cos x. Okay, beta. So this is your answer. Okay. Isn't it? So
Yes, sir.
from tomorrow, I will be taking the lecture in the fastly way. So thank you for today.
Thank you, sir.
But that is clear, no? Have any doubt here, beta? Everything fine?
Yes, sir.
Yes, sir.